Hi all, welcome to part 5, what I believe is the bug cleanup. So the script was generating a few bugs. Most of the bugs are done to the cone. The cone's collision was set to collide with itself. This was generating double, triple, quadruple overlap events on end overlap when the actor was being destroyed. The way that you can go back and debug this in your build is by adding a time delay before the destroy actor and hitting F9 on the destroy actor to create a marker. Bump this delay up to like a second, and that will give you enough time to actually run away from the cone so that you know that this state is triggered for sure, and then you can debug and step through the code. Now let's go over the changes that have been made to address all of it. The first, possibly most important one, is that we are completely locking out the thick function from ever even running based on a new Boolean variable. You just create the Boolean, set it by default to inactive, and then put it in here on the begin overlap. It's actually at the end. Yes, this begin overlap is entirely different than what you remember, because what you remember only had the overlap actor. So let's go through this since I mentioned it. So we're checking the value of is dynamic. That was a value added to create this effect. If this value of is dynamic, which is controlled by the camera itself, right here, Boolean is dynamic, so you can choose when you manually place cameras to toggle that off and tell it that it's not a dynamic camera and therefore it should not be treated as one. The dynamic camera takes the old pathway, so it only sets the overlapped actor. This option instead allows you to control whether or not you want it to change your the way it works, the way it is activated. It's best to demonstrate it, so let me do that. If I go in here and play, if I go this way, the camera changes. If I enter the field this way, this is no longer true, and that is based on that sign math that you saw between the player rotation and the actor rotation for the camera. Again, coming back in here activates the camera, coming back from here activates the camera, but coming back at a degree that is somewhat head-on will not trigger the camera. That is the custom camera that got created. If you remember, it is based on the line trace result, so when it's something like this where you're looking inside the tunnel, you won't get a line trace to come up at all, or a camera to spawn at all. Then we have, going back to the code, so we have this new be head-on change option that is an option added to the camera management that you can toggle on and off on a per camera basis. And then we have our vector math. So it's fairly simple. We're getting the actor rotation of whatever actor it is that is overlapping. We're getting its forward vector, and we're looking at the forward vector of the camera. If they're somewhat similar, and we'd use a find lookat rotation to do the sign map for us and compare to the original rotation. If they are about 25% similar, well, I say 25%, but I'm not sure that 25 actually means percent. I hope it means degrees. In my mind, that means degrees. In reality, it's probably got nothing to do with degrees, and I just got lucky by punching in a number. This last branch then is the one that prevents it from working. So if this value was true, then we are not triggering it on. We're not moving into the camera. We delay the setting of the active to obviate some issues that we had the delay. And speaking of delays, an important thing to note is that I removed all of the delays from everywhere, including from here, and they're only available here after the target view would blend, so do leave that one in. Next is the fact that coming in from the event external camera is toggling a dynamic variable here. The plugin that I am going to be publishing actually has a dynamic camera return node. This is part of the interface now, along with the camera ID. In the end, the get dynamic camera value isn't really even used, I don't think, anywhere. So I do not believe that we need to worry about that. Let's finish going down the line on the on-tick event. So we check off whether it's active. We double check that it's not being destroyed. This is mostly just a precaution. We checked if the overlapped actor is valid or not valid, right? And it will almost always be not valid if you're starting here, but because it is active, because of this active and it only running after this has been triggered at least once, then we're actually getting some meaningful results from this. And we're using, again, the active value along with the result of however many overlapping actors are available to drive a manual end overlap. Now the manual end overlap is injected not at the beginning of all of this because of the overlapped actor possibly not being valid. So we're injecting it over here, and yeah, I mean the overlapped actor might not be the same, and that's what I mean. It might still be the old actor, whereas something else might be overlapping. So we just move it down the line, and this seems to work fairly well, at least in testing. We added the active disabling here. That's important. You need to add that in as well. This is the full blueprint there. Okay, going back to the tick. So we ended with this branch. Let's continue looking at over here. So we're checking that the actor component is equal to nothing, and if it is, we proceed with our logic. The logic is taking a look at the components of the actor that implement the interface, and if we have a valid result of that, we check again that our actor component is not valid. Call this paranoia, if you will, and we set the actor component to the one that we pulled from the get 0, and then we call our event for the external camera. That wraps this up. Compile, save. Let's take a look at, so the we have a few things here. Let's review the on-tick event, right? We had the whole logic for the event begin play, and we have this logic here. I'm not sure if this made it into the last video or not, so I'll just reiterate it. Basically, this box over here, and I'll comment it, prevents the automated camera based on the Z. So basically, if the camera is looking, you're looking from the floor up, this prevents the code from running. With the code no longer running, and no longer running for where the camera is set to be in first person, and not running when the camera is external. So if the camera is not external, this code can run. We are then proceeding with the rest of the logic, which I don't believe is changed by much. We're getting the child component, we're checking whether it's valid. We're getting our spring arm values and doing the math just like we did before. There's a slight delay node over here. Mostly this was added, actually. Yes, and this was added to make sure that the line trace and the camera doesn't get spawned too early. So if you have issues with how quick it takes before it takes over, you can change this delay node. Moving forward, this is all the same as before. We're creating the line trace. If the line trace result was false, now we actually flag that we're using the external camera. That's new. And we create the camera and we set the options for it. Now on the automated options for the camera, because of the way I introduced them for myself, the head-on change for the dynamic, why do you have to do that all the time? The head-on change for dynamic is actually flagged to on. So this one flags it to off, allowing the transition to happen like it normally did before that value was introduced. Under head-on change, you'll see that it's triggered so by default. So that's how that one works. In the blueprint interface, nothing particular because we didn't end up actually using them in the end, but we have the get cam ID option and get dynamic camera. Get cam ID I believe we used before, and get dynamic camera is just the one that returns the value for dynamic camera being triggered. So technically you could use that value in here to determine if you have an external camera or not. But it is not needed because of the active switch. So turns out that it is working quite well. Trying to think if there is anything else that was changed off the top of my head. I don't think there is. So with that done, I want to use an inadvertent feature that is created and that creates this effect. And I want to make a small single track where the player only really has to push the forward button. And I realized that we never implemented a way for the camera to stop giving your rotation if you did not want it to. So that's kind of a requirement, I would say. We have the input for the external camera, and we're using the external camera rotation in this return node, but we should also consider using the non-return in case we don't want it to. To do that, select float. So that will pick A, and we'll pick A, and then we plug this in here, and that's our return. Now, what do we drive that by? Excuse me. So from the inside the external camera, let's go see what external camera really is, right? We're passing the external camera here from this value, so is a copy of self of external camera, and we have the call over here. You can see it passes self. So let's add another management variable. Allow control take over, and move that into the B section. Alright. By default, the default value of this will be yes, allow the takeover. On this specific camera, which is the one that I was testing, I will disable the allow control takeover. And inside the where are you? AC operations, inside the cam ID. No, where are you? The rotation, control rotation. I will then take this value again and pull out the reference. If I could only remember what I named it, control takeover. So if I type takeover inside here, I should be able to find that. Maybe not, because it isn't cast. Trying to think about what the best way to get that in is effectively. It is a reference to self. We just cast it then. I don't like casts, but it is one cast and it does solve the issue. Yeah, where are you? Yeah, control rotation. Okay, so this will be a pure cast. Cast to BP external camera. Convert to pure cast. And I don't really care whether this is true or not. I just want to get that variable. It's like control takeover. There. So we know that the external camera is valid. Because the external camera is valid, we also know that it's always the BP for external camera, unless you made modifications on your own, and in that case you will be on your own. So this is the whole pathway, and it kind of works by just pressing the forward button. In some cases it doesn't, and that is by design. Oops, and then you missed the jump. So the one that I really wanted to test anyway was this camera here, because it's like an action shot and it's still taking over my control. Why are you taking over my control? Allow control takeover is off. Player controller should be looking. Whoa, watch it. I wanted an F9, thank you. Interesting. Well, okay. It might have been a fat finger on my part, or a fat noodle in this case. I wonder if I can do something stupid like add a slow-mo when you're inside the camera. Let's do that. I'll include it as part of the project. I just haven't played it with that particular option. So like before, we already have the cast from before, but let me see if I can affect slow-mo over here. Game speed. I do not recall how you do that. Set time dilation. Okay. So we're doing this at the beginning of the overlap. If a special time dilation by default set to 1, by the way, so that there is no time dilation. If time dilation is not equal to 1, apply time dilation. And the opposite of that when you exit the camera, so before the destroy node, go back to regular time. Okay, test this out. Let's give it a time dilation of 0.5. And let's see how that works. I have never actually played with that. Whoa, slow-mo. It actually works. Excellent. No, I made it. I made it. I made it. Grand finish. Yeah. Alright guys, thanks for watching. Have a